Excellent. Okay, so I'm just going to seeing it's great to see that there was so many people looking to set up a new site. So I'm just going to go through some details about how to choose an appropriate site. If people, we can open this up a little bit. So if people want to jump in and ask something, I won't be monitoring the chat, so I won't see it straight away. But if you don't mind just turning on your microphone and jump in and interrupt, that's completely fine. So now we're just going to talk about how to choose an appropriate site. And this is just based on my experience so far. So some ideal site, what makes a perfect CoastSnap site? Well, it's a bit hard to give an exact answer to that. But here are some things that I found, some ideal site characteristics, and maybe if other people have operated some sites would be interested to share their opinions too. So first of all, ideally what we look for is a site that looks along the coastline and not out to sea. And the reason for that is related to primarily to when we do our shoreline mapping out and our rectification, is that the accuracy gets a lot better when you're looking along the coastline, as you can see in this photo here. Secondly, from an elevated location. Now, basically, the more elevation you have, the greater coverage you're going to get of the beach, and I'll talk about that in a sec. In Southeast Australia, we're fortunate enough that we have a rocky embayed coastline, so we have quite large elevated locations to put a lot of these stations. Nevertheless, if you don't have a lot of elevation, that doesn't mean you can't put up a station. And you can see this station here that we have here in Newcastle in Southeast Australia, that's only at about 5 meters just on the dunes itself. So, and that's fine too. It just means you won't get as much coverage. Thirdly, we want to have the thing that we're interested in. So if it's the shoreline, in the foreground and the center of the image. Because basically, firstly, the accuracy of the, as you can get potential more distortion effects at the edge of the image, it's better to minimize those by having the thing that you're interested in the center. So the shoreline, or maybe if it's a cliff, looking at cliff retreat or something like that, make sure that you try and frame it in the center. Fourth thing is, as you saw, we rely on having stable points across the image. And by stable points, we mean things like buildings. Could be anything from buildings to hills in the background. For instance, if you see here a feature in the background, which is very useful. Just things that don't change. And we need that for, firstly, for our image registration that you saw earlier, sorry. And also for our shoreline rectification. So you saw us actually clicking on places with known points. As a side point, you don't actually have to be able to measure that point. And I'll show you a few tricks later tomorrow where you can actually use a thing called virtual ground control points, where you actually measure other areas and get a good geometry solution. And then you can use that to click on things like, for instance, this distant hilltop, and use that as a point of reference for our image rectification. The next thing, firstly, you want a site that is dynamic or interesting. It's not particularly exciting for the community if things don't change over years. For instance, if you're dealing with a stable, low energy beach or something like that, it's a lot more interesting when you get some big changes. So whether that, whether it's a cliff, you know, could even if you're anticipating an event or something, if there's something that could happen in a few years' time, like a cliff collapse or something, could be interesting as well. But you need to try and maintain that community engagement. Next thing, sufficient pedestrian traffic. So obviously you need a place that's discoverable. I would say though that pedestrian traffic is not the be all and end all. As long as you empower and just at least 1 or 2 community members to take their regular photos, it doesn't matter if you don't have a lot of pedestrian traffic. And a lot of our stations, they're successful because we have these 1 or 2 very keen community members that are willing to get excited and do their daily photos. And that's sufficient to get a fantastic record of changes at that site. So yes, it's important, but it's not the be all and end all. A next factor what we find is, this is particularly related to those social media influencers, particularly for some sites we find if it's a particularly good photo, if the photo actually looks like something that you would take a photo of anyway, and particularly if it looks good on Instagram and people, particularly young people, want to show off their photo, then that's a really good incentive. And so we found some sites, and I'll talk about this later, that we've actually seen some quite significant Instagram traffic simply because the photo is just very good. Having said that, so if you set up a photo of a particularly ugly location that no one wants to take a photo of, you're guaranteed you're not going to get many photos at the same time. So try and keep it to places where people want to actually take a photo of, and then you can harness that appeal and get a lot more photos. Obviously, safety of the site is important. We've had some issues installing stations close to roads, by the side of roads, and there's that fear that you could have a car cause an incident or something like that. Likewise, if you're putting sites at high elevations close to cliffs, make sure that they're within safe areas and things like that. Low vandalism risk. So some issues, I know in some countries have had some issues with the stainless steel camera cradles being stolen themselves. So just be wary of that. Minimal visual impact. One of the things we're careful about is that a lot of where we're putting these stations are on nice lookout points anyway. And by their very nature, people like to get involved with community beach monitoring, but they don't like it when their pole gets in the way of their view. So be very careful not to affect the visual impact in a negative way, the amenity of the site, by sticking your pole right up there. And we've had incidents where a pole has been set up on a place where people like to put a picnic rug and watch the sunset, and now they can see a pole in their place, and the community one night went and got a shovel and stole the pole and expressed their anger that way. So be very careful of that. Another thing is, one thing to consider is that you cover the full range of coastal variability at the site. So just be aware that while the beach may, when you visit the site, may look like that at that particular day, a lot of sites by coastlines, by their very nature, are dynamic. So you want to make sure that you're covering the full range of eroded conditions and accreted conditions as well. Some ways we do that is by actually going back to Google Earth images and looking at the chronology of the site and seeing how much the shoreline has varied in the past. Finally, we've also had these issues that the site doesn't succumb to erosion itself, and I'll show you some examples of that actually at this site here. I'm just going to show you some. Let me see if this works. Click on the before and after slider. This is our site in Stockton Beach, which is an erosion hotspot. So that's why we put it there. And this is what this is the local newspaper, the Sydney Morning Herald, developed. I sent them the photos, and they made this nice slider of when we had a big erosion event, which I thought was pretty cool. And you can immediately see the changes. Anyway, that was a nice thing from that. But yeah, So this is, coast site doesn't succumb to erosion itself. This is one of our sites. This is by the University of Federal of Santa Catarina, who are monitoring the site in Florianopolis in Brazil. This is their station here. And this is just their station. I think this was just a few weeks ago where there was so much erosion that it actually caused significant damage to where the actual crater was located. I've had the same issues here. This is in Stockton, where our station was actually blocked off for quite some months due to the erosion, and it was actually dangling over the edge. So that station has actually been moved back a couple of meters now. Some things about elevation and shoreline coverage. Like I said earlier, the higher the elevation, the better the coverage you get, but it doesn't mean that you don't have to, you can, you're not restricted to high elevation locations, because this is our site at Blacksmith Beach. It's at an elevation of just under 5 meters above the above sea level. And here's the rectified image from that beach. And what you find is that because it's only 5 meters, you're only getting about 300 meters of shoreline coverage from that. On the other hand, this is one of our newer stations at Browley in southern New South Wales, in Southeast Australia. A beautiful location. This photo is actually taken, I think, by Andy Short. But anyway, this, because he lives down there, this is at an elevation of 25 meters. And because it's at 5 times order magnitude, what you can able to achieve by that is that you actually can get coverages of up to about 1.4 kilometers. And so if I was to put a number on it, I haven't looked too much into it, but I'd say about 1.5 kilometers is about the limit. 1 to 2 kilometers of good shoreline extent, depending on the elevation. Obviously, because at a certain point, if you go too high, you start to get too far away from the beach itself again. So 25 meters, I would say, is a very good elevation. 30 meters, so anywhere between 20 and 40 meters is very good. But yeah, if you have a low elevation site, it's still possible, but you're only going to get coverage in the order of a few hundred meters. Yeah, another is resolution and shoreline coverage. So by the nature of coastal imaging and the rectification process is, if you're having low resolution images, you generally get less shoreline coverage, because effectively by the rectification process, what we call the pixel footprint gets bigger and bigger the lower the resolution you have. So these two images here, they're taken at different times. The one on the right is taken at sunset. That's why it looks so dark. But concentrate more on the resolution. So the one on the left was submitted by email, and you can see that even at large distances from the camera, the pixel footprint is not too bad. And notice how it's better in the cross-shore direction than in the longshore direction. And that's particularly important when we're looking at shoreline change. And that's why we try and choose sites which are looking along the beach. So we're kind of minimizing the effect of this pixel footprint, particularly in the cross-shore direction. So we're still getting accurate cross-shore changes, which is what we're most interested in. On the right here, this was...
Can I ask a question?
Yes, Chris.
Hi. Can you tell me whether or not there's a difference with app images in comparison to Facebook and email?
With the app, so we haven't tested that yet, but the app is going to be in full resolution. So something like email, so a few megapixels. So I think that will be fine. So the issue is like Facebook and things. So what you do find is you get slightly less coverage. So with the full resolution, you can get 1.4 kilometers, but for things like Facebook, you're probably reducing that slightly to about 800 meters. But I'd still say even with low resolution, you can still get very accurate shorelines. And if you look at our publication, we found that there was actually not that much difference, at least within the 1 kilometer kind of ballpark between the Facebook's image compressed images and the original resolutions. So don't let that scare you too much that you're having 0.2 megapixel images to try and look at shoreline changes. What I'm going to do now is just go through some example site locations. So again, this is our blacksmith site that I was talking about earlier. That's at 5 meters above mean sea level. It's a freestanding stainless steel post, and you can see that the council there wanted to mount the signage on the rock armor units there. And so this site is located along a breakwater. Let's see if I can click on that. I should point out that all of our sites are on Google Maps, so you can actually even rate it if you want. So we put the pin up, and I would encourage you to do the same. We couldn't find a nice, particularly a nice category to classify it, so I chose Science Museum, but anyway. But here it is. So it's along the breakwater, looking along the coast, as we were saying. The reason why one of the challenges was to position it to capture the full range of variability. So we went at that site to look at on Google Earth and looked at the range of variability and try and put it at a location along the breakwater that would capture that variability. So it'd get both the accreted beach, but also the eroded beach. So that's something to consider. The interesting thing about this site, so this is our design this is a SketchUp of our design that we sent to get fabricated. You can see it's 1.2 meters high. We use 316 stainless steel. We actually use quite a thick stainless steel. And yeah, what else about it? Yeah, so 1.2 meters. So I guess you want to be careful. You want to encourage children, I guess, to participate as well as adults. So just be wary about that, making sure that access is fair. This is actually the sign that they came up with this. So we gave them, and I should say, we can provide this template here for you, but the local council actually wanted to actually come up with a bit more information about both CoastSnap, but also expressing some information about dynamic coastlines and things. So I think this is a really nice sign. You know, welcome to Blacksmith's Beach. Has some information and it explains a little bit more about what is CoastSnap and how does it work. And I'm not sure if that's a reason, but with this site, we actually get very high community participation. And I'm not sure if maybe the signs there explain a little bit more. They are on an because they are quite a big A3, I think, or A2 size, so you can get to fit more. So that's the challenge. With the app, and we may think about actually having this information with it like a QR code where you can actually get some people click on it and explain that. But this is community images from the blacksmith site. First things you can see is it's been going since August 2018, so getting on 2 years now. And we haven't seen a drop off in submissions. We're getting a steady participation, high engagement. So at this site, we get about 9.4 images per week. So more than one a day. So we've had getting on 1,000 images submitted from this site. And interestingly, at this site, it's entirely that local kind of champion kind of area. So 91% of our images are submitted via email. So that's an interesting one, and a lot of them are the daily regulars. So that's, as I was saying, in terms of traffic, it's not a particularly high pedestrian site, that breakwater, but because we get those regular daily users, it's very much a successful site. And here's the kind of time-lapse videos you get from that. So you can see it's looking along the beach. At the moment, it's in an eroded state, but it actually grows quite a bit in front of the camera, but captures that full range. Because it has those stable features, both of the rocks in the foreground and things in the background, it's able to do the rectification, the registration quite easily. You can see how much it grew just there. There was some minor nourishment, disappeared. So yeah, more than a photo a day, so we can get some really nice time-lapse videos like this, and the council is really happy with these types.
It's just a quick question, if that's all right.
That's Joe.
Just wondering how you got your ground control points in that particular site, because it doesn't look like there's too much sort of solid structures in that pane. Cheers.
Yeah. So as I said, you only need, theoretically, you only need 2 ground control points. I don't have it here, but what we actually use corners of rocks. So one is just here where you can see my cursor. So just looking at some features on rocks. And then if you see in the background, there are some buildings there. So corners of buildings are useful there. So just with a couple on the rocks and 1 or 2 in the buildings, you're able to get a rectified solution with that. So that's why it's important to look out for. One of the other things that I'll show you tomorrow is that there's also the ability to do some more advanced techniques where you don't actually have to go and measure the ground control points, but you can actually use features like the top of a hill or anything that you can kind of click on in a picture, and but not be able to actually measure it, which is a nice feature. Just as an interesting contrast, this is another one of our really popular sites. This is at Byron Bay in New South Wales. Maybe some of you have actually been there. It's a very popular tourist location. This is our site here. It's a very simple design. You can see the dimensions of the design. It's just simply attached to a treated pine cylindrical post, and just a sign there. It's a simpler sign. One thing I just want to point out about these dimensions is, see this gap here, which is, it says 35 millimeters gap here. I would suggest making that a bit wider to about 50 millimeters, because what we find now with some of the more more recent model smartphones is that the lens is probably more towards the center of the phone. And you do with 35 mils, you start to get some photos showing a bit of gray on the corner of the camera cradle, which is not desirable. But so I'll just show you this site, Byron Bay. It's at a lighthouse. It's actually the most easterly point in Australia. Let's see if it's even in. I think it's down here. Anyway, it's not in this street view image, but it's just on this post just here, if you can see my cursor. So a lot of people visit this lighthouse. See up there, a lot of people walking past, and it does have a spectacular view of looking along the coast. So and also Byron Bay is a very popular destination for social media influencers as well. So if you know the area, it's has a lot of it's kind of a bit of an alternative kind of relaxing area, and a lot of social media people live up there, and so it's very popular with Instagram. I'll just click on the Instagram. Let's see if this. So this is just the hashtag Byron, CoastSnap Byron. You can see there's over 1,400 posts. This is just looking at them. This just gives you a bit of an idea of what you get. You see a lot of people taking photos of using the cradle, but also you get a lot of random stuff too. And that's a challenge that you've got to be wary of. So people just tag, you kind of become a victim of your own success in a way that I think there must be programs that recognize that if a popular hashtag for the area, and then they just use that hashtag for them to attract more of their own people coming to their Instagram accounts and things like that. So look, you can see probably about 30% of them are not actually taken from the cradle. So that's just something to be aware of. And one of the things we're working on is there are quite simple machine learning techniques to filter out that kind of stuff by just feeding in what you expect the image to look like, and it could give you a classification of that. And we hope that if people want to develop that, help develop that, we'd be very happy to have some participation. But this is, so in contrast to the blacksmith site, this is the breakdown. So we're getting similar kind of photos submitted, about 8.2 per week, but interestingly, we're getting 65% submitted via Instagram. So if you're not using Instagram at some sites, you're going to miss out on a lot of potential contributions. Some interesting thing here is, if you notice here, this flat line in the center, that was actually when they were doing construction on that footpath, so it was blocked off for a period of time. But this flat line along here, you can see the influence of COVID-19, where tourist numbers completely dropped off, or people going out. And you can, but also you can start to see a gradual drop off as well in the number of things, because you may have heard that earlier in the year in Australia, we had quite severe bushfires, and even that area of Byron Bay was affected. So less tourists and less people. There's a lot of smoke in the air for quite an extended period of time. So that affects things, but you can see traffic starting to pick up again at that site, but at a less regular rate, obviously, because you've got a lot less tourists visiting the site. But this is what it looks like. You do get to see some really interesting changes in the coastline. This is quite from a coastal geomorphology perspective, it's really interesting because it's a double barred beach, and you can see some interesting dynamics of coupling of the sandbars and things like that, and how that affects the shoreline. Once again, you can see the image registration algorithm working well and keeping all those, while the images move around a lot, the registration controls that, so it can concentrate on the changes. I'm just going to go through now some example sites of different locations set up globally. So Mozambique, they've opted for a more simple design, just using a wooden post, which is quite nice. I believe they've had some issues with it being stolen, which is some of the challenges you can have. Our particular sites in Southeast Australia, our stainless steel posts, we actually use security bolts as well to really bolt them in as well, which prevents potential theft. That's just a point. Santa Catarina, you can see there. So other sites, like in Galicia, they have the challenge of dealing with multiple languages. So I think you can see 3 languages: English, I think, English, Spanish, and Galician. I think, is that right, Rita and Ivana? Probably. Yeah. So this is another one. One thing I should point out, though, if you notice the Southeast Australian sites, there was no seasonal signal in the contributions. Now that's because Southeast Australia is fairly temperate climate, and we're pretty lucky to have warmish beach weather all year round. But of course, in other areas, I recognise it's not like that. And having visited the coastline of Emilia-Romagna in Italy in the wintertime, I know how desolate it can be at a lot of these sites. So And this site in CS Islands, I think it's Rita. I think it's only accessible in the summertime by ferry, so you're simply not going to get almost any photos in the wintertime by the fact that it's inaccessible for most people. So this is with the Plymouth Coastal Observatory in England. They're setting up quite a few sites. And you can see the QR code there. Joe, I think you're there. And Joe, do you want to say a couple of words or something? Or you there? No.
Oh yeah, sorry, Mitch. Yeah, so this is just a project that we've got in line with the Environment Agency and a couple of local councils in the southwest of England. And I think we're going to hopefully unveil about 9 or 10 sites over the next couple of months. Progress has really slowed down with COVID, but hopefully we're picking back up soon. So, cheers, Mitch.
Thank you. I should maybe a good idea actually if people want to. I don't know if Kari, are you there about Mozambique?
Yeah, no. Hello.
Yeah.
Yes, we are working in Mozambique. This is an interesting site because we are having many issues with vandalism, lack of participation. Yeah, it's difficult to involve people. We've been working at the beginning of the project, running 3 workshops in the 3 locations where we put our sites. But even that, involving the local community, fishermen community, all the NGOs from the sites, it's been really difficult. It's gonna be in August 1 year, and it's been quite challenging to involve people to take pictures. And we have issues with vandalism. The information board was destroyed. And then during the COVID, we had 2 of the sites where the stainless metal was stolen too. So it's been quite a challenging one. But now in TOEFL, we have some pictures, and we are trying to analyze and have some results for this site in particular, the one we can see in the picture.
Yeah, so I don't want to paint a completely rosy picture of everything. There are challenges that you got to deal with depending on the location and things like that. I don't know if anyone else, Rita, if you wanted to say anything about Galicia, if that's.
No, it's okay. That all that you say is okay. Okay. Yeah.
So when I was doing research for this, I found out that there's now a network of 4 sites in India, which I think is fantastic. Is anyone there from Indian, from Kerala? No. That's okay. So anyway, that's their design. This is a station in Fiji here that we installed. This hasn't really been that successful. We just did it more as a demonstration, just to demonstrate the potential, but it's actually located on the grounds of Shangri-La Hotel. But we haven't really been doing any community engagement, so haven't had that much success at that site. One in Suriname. So very recently in Western Australia, this is University of Western Australia. They've got up some designs. I particularly like this design. I think, thinking about how it blends in with the site is good, and they've painted it white there, which is nice. And here as well. So I think that was just last week. They've installed about 9. So that's up and going now. And Belgium. So this is in Ostend, in Belgium. And do we have any Belgians here that can maybe comment on how it's going so far?
Yes. Hi, Mitchell.
Hi, the photo.
We've been busy now for a month, and we have, I think, like 30 images. but also because of the COVID, it had a quite slow start, but we did pick up a bit of press when we released it. You can see my flattering picture. So yeah, it's going, at the moment it's going good, and we're actually in the process of setting up a second station in Belgium in cooperation with the VUB, the University of Brussels, and several other projects where we want to incorporate the CoastSnap station. So things are picking up in Belgium as well.
Fantastic. Yeah, obviously it's not the ideal times to be setting up community monitoring stations. Scotland, Stonehaven, I think they've been super successful. Anyone there? No?
Yeah.
Oh, yes.
Sorry. Yes,
Demetra.
I'm Demetra. Yeah, hello. Yes, it's been very successful even during COVID. I think we had people on their daily exercise to just take photos and stuff. But we are from a consultancy, so we don't have the luxury of working on that. So we are still waiting for the council to pay us, and hopefully we can get some results to analyze the tons of images we have.
Yeah.
So, thank you.
Yeah, exactly. Yeah. So doing it as a consultancy, obviously you need to budget in the time to map the shorelines and things, because it's not like you can just install it and then it just, things happen magically.
Yeah, right.
France, Youssef? Or
yeah, I'm here. Hello, everybody. Thanks, Mitch. Yeah, I think that CoastSnap is working fine in northwest of Brittany. We already have actually 3 stations, and we managed to implement 2 other ones by the end of the summer. And we have seen that there is a good community contributing to take regular images. And we are working with around something between 25 to 35 images a month, which is really good. So yeah, it's worked fine, and I'm also pretty happy to see several colleagues from France interested to implement, I think, as soon as possible, more stations in France.
Yeah, that would be great.
Yeah.
I guess one of the challenges with the Brittany site is it's a macro-tidal coastline, as you can see, very flat. So the extent to which you can actually detect shoreline changes would start to become an issue, would be my concern. So yeah, have to be very careful on macro-tidal coastline. But yeah, thanks for that. And Cascais.
Hi everyone.
Yeah.
Well, our experience is because we have so many stations, so 14 stations. We have stations that got vandalized. So now I don't know how many stations are active actually. I have been on maternity leave, so I have to go to the stations now. And with COVID, everything was in lockdown, especially in Lisbon, which is the most affected area right now. So we are still hoping that we have, I know that we have some stations that are active because we are receiving pictures by Instagram, but I don't think that all 14 of them are active now. Actually, as you can see, we already have to replace the structures. They are becoming a little bit rusty. Yeah. So we have to contact the city hall and talk to them, because they were the ones that were responsible for creating those structures. They were quite keen on changing the CoastSnap layout, so the colors and everything. I talked to Mitch at the time. They didn't want to go with the CoastSnap layout, but we have the CoastSnap brand there. And we use the CoastSnap Cascais, but the city didn't want the signs to be equal to the other places. Yeah, so that's what's an issue with us.
That's typical. I mean, obviously, certain local governments, they have quite strict policies on signage and things like that, which is happy to work with. So,
but I think it's going well, very well. The city is also interested in maintaining the stations, which is good, but they don't want to pay for for the work. So now I have some budget from my university, some personal budget, and I think I can manage to maintain the sites. I might have to downsize, sorry, a little bit. I don't know if I can maintain the 14 stations. I have to talk to the city about that. But I think Cascais is going to be able to maintain some stations. So I think it's going to work in the future as well. So thank you.
Yeah, so that's a good point. What I'd suggest if you're looking to set up a new site, I would suggest you do the focus on establishing maybe one or two pilot sites first, and do a proof of concept in that particular area before rolling out 10 to 20 sites at a location. I think it's better to do a staged rollout rather than putting a whole bunch of. Yeah.
I'm sorry, we wanted to downsize, but the city said, let's do all the beaches.
Yeah.
And so we had to oblige to them, because they were paying. So, but of course you are right. Yeah, you should start small for sure.
Thanks, Christina.
Thank you.
So Bournemouth, I'm not sure if John or Chris are there. This is a site in the UK, in England. New Zealand, this is on the Coromandel coast in New Zealand. I'm not sure if Tom's there, I don't think so. I don't think that's been so successful at the moment, this particular site. Nag's Head, this is in North Carolina. This is again on a pier. It seems to get regular photos. I don't think there's anyone online today from that side, but you can see they actually use the same design as the Blacksmiths Beach one, which I think is a nice design. We have the PDF of that, but we don't have the Adobe design template, unfortunately. I think this one takes the cake though. This is in the Northwest Pacific. This is actually, I don't know what this is. This is a local sculptor got the idea to design their station of a silhouette of somebody taking a photo, and you put the smartphone where she's taking a photo from. But yeah, that's an interesting one. But if you know the people from the Northwest of the US, they're interesting people. So just tips for a successful CoastSnap site. So citizen science, it takes commitment and passion and obviously funding to do that. I'm fortunate that I'm an academic and can do this as part of my role. But yeah, obviously not everyone's in that luxurious position. So often the key to a successful site is, as I was saying, is simply one or two local champions that submit photos daily. So maintaining community interest is key. Need to see results, otherwise community loses interest. So some of these local champions, I'll say, they've been keen to take photos on a daily basis. They do it, sending the emails. They do it for 6 months, and then suddenly they stop. And that's a challenge to people probably get bored or move on or things like that. So I think as we move forward with the app, I think we're going to have a bit more excitement. You'll have the leaderboard and a bit more feedback, obvious feedback, rather. One thing I'm wary of is with emails, it's a bit of a one-way communication. There's people send emails every day. I do my best to actually respond sometimes to them just to keep them interested in things like that, but that's not ideal for a scalable solution. But community engagement seminars are very useful for recruiting these local champions. So what we find is, this is me giving a community seminar. We find that they go away, they get excited, they tell their teenage kids or something, and through that process, you ended up recruiting these people who end up taking a lot of photos for you. because they get what you're trying to do and they understand it, and they know you now and they want to help. And then, as I was mentioning earlier, new developments with the app, the CoastSnap kit, and education packages. They're going to be interesting, and I think will make it a bit more exciting as well, and hopefully get a lot more engagement. All right, so that's about that, setting up a CoastSnap. So I think, is there any questions at all? I'm wary of the time, so I want to. The next sections, I'll just warn you, are a little bit dry because we start talking about image databases and things like that. So if you're more looking at from the funding side of things rather than the operational side of things, it's maybe a bit slightly boring.
Can I just ask a quick question about the app again?
Yeah.
Is there a special rate for public sector or academia for that? Because I've looked online at it, and the prices, well, they vary from a very basic package up to obviously a top flight package.
Yeah, so we've actually paid for, Chris, we've actually paid for the app ourselves. So what you see online is actually the cost that we've covered for the actual app. So Spotter on themselves, they have it's not on their website, but they have a basically on a per country basis data handling charge, and that's basically to cover because images are uploaded to at the moment Amazon Web Service, and so that comes at a cost to them when there's image traffic of people submitting and downloading images. So they do have need to recoup their costs in that regards. I can't remember the details, but it works at about, per country, it works at about a $10,000 per year, kind of US dollars. It's about a bit less than $1,000 a month. That's on a per country basis. So this is where funding wise, it's going to require some, if people want to use the app, then there is some kind of charge related to that, and that needs to be worked out in terms of funding on a country by country basis. Is that clear?
Yeah, sure. Okay, thank you.
It's okay. But
Hi, Mitch. I've got a question too. Oh, sorry.
That's okay. No, go ahead.
Do you want to finish what you're saying first? I thought you're done.
No, I was just going to say that we've actually covered the cost of the of funding the entire app and the website, so that all those initial upfront costs by being involved in this have been covered, and having it in 6 languages as well. So, yeah.
Hi, Mitch. It's Tony Dolphin, masquerading as Nkani. Just a quick question: when you're looking at designing a site, how do you determine the tilt angle? How do you actually determine that in the field and then get that into your metal cradle?
Yeah, that's a good question, Tony. So what we find is there is quite a lot of flexibility in the tilt. So it all just depends on how much kind of sky you kind of get in the image, but you do have quite a bit of play in how much tilt you get. Generally what we do is we take, if you can see this kind of contraption here, so you can just go to a site with a tripod kind of thing and just take your smartphone and so just download an app. If you can see, people can see that at all, but it's like an inclinometer.
I have the same.
You have the same, do you, Rita? So it's just a matter of like setting it up on a tripod with the inclinometer, and it'll give you basically the pitch of the image. But what you tend to find is that, look, for most moderate elevation sites, it's probably about 15 to 20 degrees. For a kind of low elevation site, you're probably looking at about a 10-degree angle, and you can kind of guess it pretty easily. And if you're out by a couple of degrees, it's no problem.
Nice one. Thanks very much.
No worries.
The question that only one small thing. I recommend for the people who install a new station to put more information in the scenes, like blacksmiths, because I think the people didn't know really how all the things are using or what is the final use of the photos.
Yeah, I agree with that, Rita.
Yes, I want to change all the signals and put more information. Even it was bigger.
Yeah, I think we could probably come up with better signages, because at the moment it just says CoastSnap Community Beach Monitoring, but to a community perspective, what is monitoring? Like, are you or something like that, or what are you actually doing? I think we can improve that, and maybe because the blacksmith site does actually explain a lot more about what it actually is and how it's being used, probably helps why we get to see so many more community contributions at that site. Any other questions before we move on? I'll just bring up the next. Okay, so for this next section, can be a bit hands-on if you want, but I'd invite you to, there's this URL you see on the screen here, tinyurl.com/CoastSnapWebinar2020. If you want to go to that now, there is a CoastSnap starter kit. And in that starter kit, did everyone get that? Let me, you should see these things. In particular, this CoastSnap starter kit zip file is basically most of the things you need to do to get started with CoastSnap. Can I send it, Paolo? Ciao, Paolo. Send the URL. Let me. Whoops. 1 second. Too many open.
Is that an update?
Okay, I just put it in the chat. So it's quite big. It's raining outside here. It's quite big. It's about 500 megabytes, I think. That's because I've put quite a few community photos already in there from the Manly site. So you have at least a sufficient amount of data to play around with. So I'll just go through. So that if you download and unzip that file, that is essentially the file structure that we use for CoastSnap, and it's only going to work if you maintain that file structure. Otherwise, you'll get MATLAB crashing, and yeah, then you'll be panicking. So just some philosophy. First of all, I've designed it so that it is really simple to use, so that most people can get up and running pretty quickly with it. And by that, I mean that a lot of the databases, I've just used an Excel system. So rather than opting for like MySQL databases or things like that, which we do for more advanced coastal imaging solutions, this is simply done in Excel, and I'll show you that. So it's very easy to change things. You don't need to be a whiz at anything to do that. So all the images that we see, I'm not personally interested in your images from your particular site. So what we do is we just maintain our own image database locally and share it between our local users on a Google Drive. So you can do the same. It's not onerous in terms of how many megabytes it is, because it's just simply, you know, having a few thousand photos, which only works out to be, you know, gigabytes, rather than terabytes or anything like that. So I think I just have pay a simple Google Drive subscription of about $2 a month to maintain that. One of the things that we've tried to do is, in terms of CoastSnap, keep it simple, try to avoid needing too much field data. So whereas coastal imaging, we tend to try and want it to be as accurate and as perfect as precise as possible. Here, we've tried to sacrifice a little bit of accuracy, which I think sometimes we get too obsessed with trying to make it too accurate. And so rather than, this is all within reason, so rather than having to rely on data coming from tide gauges, which means that you will often have a delay, like at our sites, we just use astronomical tides. But we do that because we know that at least in Southeast Australia, like the non-tidal anomalies are pretty small. So we just need, so it doesn't really relate to cause significant dramas in terms of just using astronomical tides. Obviously, that's not the same for all coastlines, particularly when you're talking about ones with low gradients, where you're really concerned about having accurate water level measurements. So maybe you want to then have to opt to rely on those measurements, but that's fine, you can do that. So it doesn't require, we don't actually use any wave buoys for our corrections or anything as well. So we don't obviously map it when there's a massive storm. We don't map shorelines because we know that it's not going to be accurate, but most of the time, if it's pretty calm, it's fine. And as the point was earlier, you don't need to overdo it. You don't need to map every shoreline in every minute, just important ones. So if it's one image a week or once a month, you can then simply capture the change from 1 month to the next. And that's what the community really likes, or maybe from this year and last year, or before and after a storm. Okay, so depending on how much data you want, you know, your level of data collection can be as small, onerous to a lot. So, and finally, I apologize, there's a question, Python version available? The answer is no. So I apologize, as I say, apologize in advance for MATLAB. I would absolutely love to have a Python version and have it open source. That's just historical, how it came about. A lot of this code was written well before Python existed. So if somebody wants to spend the time recreating all of that into Python, by all means, you'll be my best friend forever. But
well, Mitchell, if I can interrupt you there,
yep.
Because in Belgium we're starting all these new stations. We're actually
yep.
thinking about using a student or someone with a thesis subject or an internship to convert the code from MATLAB to Python or R. So that's something
yep.
that we're thinking about, but we're not sure if anyone already has tried this or somebody has experience or wants to cooperate on this, maybe some other institutes. That would be interesting for us as well. Yeah,
I mean, that would be fantastic to see. It's not a trivial thing to do. So having the codes to rectify and solve the geometry solutions for the range of intrinsic and extrinsic parameters requires quite a skilled expertise. So yeah, and then to build up the GUI in that kind of thing. But I'd be very interested in, and if other people are, I mean, it'd be a great collaborative project. You know, I'd be very welcoming of it. But it's probably not going to happen in the next 6 months, I'd say. It's probably a long-term thing. All right. So CoastSnap database structure. So if you unzip your folder, you'll find a folder called CoastSnap, and then if you click on it, it looks like this. Pretty self-explanatory. Code, all the MATLAB code is is available there, and that's from the GitHub site. So if you actually look in the code directory itself, there's just a README file, and that's because the code's always being worked on primarily by myself, and that's on the. You can simply search it on GitHub, and so we'll go through this more in detail tomorrow when you set it all up on your computers. Oops, I'm in the wrong. But that's where the code lives. The database is home to the CoastSnap database Excel file, and that's the most important file in CoastSnap, and I'll talk about that in a sec. Images is where obviously all the images are submitted by the community. Pretty self-explanatory. Shorelines, obviously, they're automatically generated from the GUI, and plus, as we were talking about earlier, these transect files which are needed to map the shoreline. Sorry, and then tide data is where we store or water level time series, and that's either astronomical or measured. Looking at the image directory, so the way that we organize it is that each site has its own directory like this. So we have our Manly site, North Narra, and it's important that you keep the site name always constant. And so whether in this folder, so it's always this _ Manly, and also, as I'll show later, in the Excel tab, the database. But if you look at the site, each site in the images has this kind of structure. Raw images is where images are submitted directly from somebody's computer or Facebook or something, are downloaded into. And then we have a file which converts them into the file format that we need for CoastSnap, and that goes into the processed directory. And then we have our rectified images are stored in this folder. Our registered images, when we do it with Photoshop, are stored there. And finally, we have a folder called target image, which is essentially the image that we use to align everything for our image registration. All right, the database tab. So I think rather than going through this, I'll just show you. Let's go directly to the Excel document, because I think you can see that. So you should have in that zip file, you should see this structure here, but the database and this Excel database. Let me just, sorry, 1 second. All right, so first I'd like to focus on this database tab here. So the database tab here is just simply where you store some of the metadata about the image. So each row represents a new image. First column is simply the username, the community member that submitted it. Second one is the photo time, just in that photo format, day, month, year, and then time in the local time. The time zone, so this is Australian Eastern Standard Time. Then the original file name. So this is from Facebook, and the Facebook file names look like this. And then the source, that can be Twitter, Facebook, Instagram, email. The type, so most of our photos are snap photos from snapshots, but you can also have time averaged ones if you've got more advanced users, and some people we actually get taking those time averaged ones. And finally, timestamp quality. So timestamp quality is related to, from a scale of 1 to 3, how good do you think the accuracy of the photo time is? So 1 being very accurate, meaning that it's probably accurate to about nearest 10 minutes. And that's something like, for instance, if it's submitted by email and you're reading directly the EXIF metadata, you know that. 2 is when it's probably accurate to the nearest hour. And that's for instance, situations where, one is also when people have actually stated the time photo that was taken at. So we trust them and we say that it's that time. 2 is if it's nearest hour. So it's uploaded 2 p.m. and it looks like it's, it looks like it's 2 p.m. It's in the looks like an afternoon photo. That's about as much as you can probably say about it. And then 3 is just when you got no idea, basically. So it's probably, photo is obviously a morning photo, but it's been uploaded at midnight or something like that. So that's the database. I may just quickly show you how then what happens let's see if I can. This is a very manual way of doing things, but let's just do a quick example. So somebody submitted it to our Facebook page. All right, so this is somebody's photo from the Facebook page. I mean, this is all manual, but we don't do this we've got more automated ways to do this, but so you just save it to, the site, and we save it in the raw directory and just copy that. I'll just open up because it's our actual database. So if it's just opening this up. All right, so this is our one. So we got a new photo. There's Facebook, it's a snap photo. The person hasn't said the time, but it's 4:50, saying 4:54 on the 20th, 28th of June. So we give it a 2. Tracy Bates is the name. Site. What was it? 28th of June. All right. So we save that. And so here's our photo in the raw directory. Now that's in its raw format. And then we just have a script which is set called raw to processed in the site. And then you run that. So it's Stockton 3. So it's found one photo in the raw directory and it's renamed it. So you can see, going back to the raw directory, you can see it's no longer there. And lo and behold, we go to the process directory and it's there somewhere. And was it 26th of July, June or something? There. So now it's all sorted nicely in the right order and it's in the right file naming convention. That's basically how that works. So I've explained some of that there. But the file naming convention is basically, looks like this. So the Unix time, which is basically the time in GMT in seconds since, I'm not sure what was time 0 in Unix, but that. And then it just has some description so you can read it nicely. So Wednesday, May the 17th and so forth. And then the site, the snap, the person, and then .jpg. And then basically everything in CoastSnap has this kind of convention. So I'll share these slides, by the way, so you don't need to take so many notes. But basically, you have the snap image. You have when it's a rectified image, it becomes a plan. When it's a shoreline, it becomes a shoreline. And when it's registered, it's just given an underscore registered. So you know you can just keep track of things quite easily, and the GUI does so too. So and that's what I just showed you, that process. Just in terms of the local coordinate system, so we survey the origin of the cradle using RTK GPS. So that's just us surveying it. We can't try and approximate basically the position of where the lens would normally be. So you can imagine that if you put a smartphone here, look, it doesn't have to be accurate to millimeters. It's just as long as it's roughly within a few centimeters, it's fine. And then we have our rectified image, and in local coordinates. So we have 0, 0 in our system is the camera coordinate. So here, where that's our 0, 0 on the left. And then we can define in our database, and I'll show you that next, some certain things. So we just have the X limit, the left, and the Y limit, the lower. And then the right, the far right bound. So, and then, so just the bounds of these 4 corners that you want to rectify to. And that, you can play around with that just so that it doesn't get too crazy and that the resolution gets too out of hand or too coarse in the far field. So unlike other coastal imaging systems, we don't actually rotate it at all. So it's always aligned north-south. I suppose we could have I think it just makes it a bit more complicated when you start dealing with rotation angles and stuff. So I haven't bothered at this stage. So some of the things in the database you need to specify are the initial rectification settings, the first one being the azimuth. So this is going back to our Byron Bay site. So this is our azimuth, it's pointing south. That's our angle there. I think that's set to 210 degrees because it's basically looking that way. So that's how you calculate the azimuth. If it's facing north, then it's 0. So just as I said earlier, it just has to be accurate to about 10 degrees or so. The tilt. So going back to that thing about the pitch angle. So you need to kind of estimate that to start off with. It's relative to vertical. So for this one, it's this angle here. So that's about 75 degrees. If it's completely horizontal, it's be 90 in the database. And then finally, the tidal offset. Now, if you know anything about shoreline mapping, so there's the shoreline elevation we assume to be constant along the beach. So we don't take into account that it varies along shore, even though it most likely does, but that's an uncertainty we accept. So what we find is, and this, when we did our experiments looking at our mainly North Narrabeen, and this is what we find often with coastal imaging, it generally tends to, depending on the algorithm, it tends to pick a shoreline above, something above the actual tidal elevation. Now that's primarily related to wave setup at the shoreline, but it's also could be related to some of the different algorithms have different offsets depending, but our red minus blue algorithm tends to pick that. And we found it to be 0.44 meters as our offset, what the algorithm was picking. Now, actually, that actually corresponds very well with the typical wave setup that you get at the shoreline if you calculate it using a formula like Stockton. This formula here, which is the wave setup, is appropriate to 0.35 times the beach face slope times the square root of the typical wave offshore deepwater wave wave height times the wavelength. So there is a way, using this formula, you can estimate, I guess, what the typical tidal offset at your particular location might be. And I've actually added in that database. Let me get that again. We're running a bit late on time. I apologize about that. Yeah, so I've got a tidal offset tab actually I put in here. So you can just put in typical conditions for your site. So in Eastern Australia, we typically have wave heights of about 1.6 meters. Wave period is typically about 10 seconds. And our beach face slope is about that. And that comes, if you use a Stockton equation, that comes to about 0.4 meters offset. But you can play around with that if you have a coastline which is only half meter. You know, the offset is likely to probably be about 0.2. Now, we haven't really tested that ourselves, but that's probably the best approach to estimate that. Okay, and so you can play around with that. If you have a flatter beach, you can change that beach face slope, and then the offset becomes about 0.1. So there's a nice little tool for you. The next thing I want to just go through, is the this database tab. So you can see we've got the database where we store each information about the shoreline, the images, and then we have the data for each site. So it's important that you keep it all the same. So Manly has to be the same as in your folder. And then we have different information that we need. So firstly, the station data. We have the local coordinates of your where your camera cradle is, eastings and northings and elevation. And that comes from the GPS survey that you saw earlier. So this one's at 17 meters. Then we have time zones that you can deal with. So in Australia, we have Australian Eastern Standard Time, which is 10 hours above in front of Greenwich Mean Time. But alternative time zone, we have daylight saving, so 11 hours becomes during daylight saving times. So that just goes into your database. You could specify whether it was daylight saving or not. In the rectification, we have, remember those local coordinate systems. So this is where you set the limits of what it's going to rectify to. So that X limit left and right in that coordinates. So you can play around with that. So I've got notes here as well on each. And then the resolution of the rectification. Now we typically make that 0.5. So the azimuth we've got here -20, so or that could equally be 340. So relative to true north. So that's slightly west of true north. 80 degrees, this site has its typical tilt. And then I've got this is basically the minimum and the maximum field of views that it's going to search through. So typically smartphones range 40 to about 70 angle in terms of its lens. So it's only going to search through that, but you can change it and make that wider if need be. Acceptable accuracy basically means if that RMS error in that solution, if it's more than 10 pixels, it's not even going to save it. But you can change that depending on your location. If you're happy to get slightly less accuracy in that, then you can change that. But I would suggest keeping it at 10. And then your tidal offset, so 0.4 for our coastline, but that can change. Your tide data, this is just basically your tide time series. Here you can see we're using this astro tide from 2015 to 2025, and we're using astronomical tides because we can easily project that to as far into the future as we want without having to rely on measured data. And that's stored in here. So you can see that's where that file lives, and that has the data it's in a MATLAB format. This transect file, I'm probably not going to go into now because it's a little bit complex. The light's gone off. But that basically is the transects that you use for your shoreline mapping. And you can see here it has a characteristic beach slope that it does that tidal correction for. And then next you have your ground control points. So these are where you've actually mapped your shoreline. You saw in my example, I was clicking on things. You can put as many as you want of ground control points and give it a good name, descriptive name. But all you have to do to simply add it is you just copy and you can paste it and add more as you wish. Just as long as you're always keeping that GCP name, these things the same. Okay. And then finally, the ground control point, the rectification combo. So this just basically you're telling the program what combinations of ground control points you're using. So here, this is in MATLAB format. So that's saying it's from or 7 basically, from 1 to 7. So there's 1, 2, 3, 4, 5, 6, 7 in here. And that's saying it's all 7. So if you wanted to use just the first, the third, and the fifth, and the 7th, you do something like that. And that means that you're only rectifying the 4 of them. Okay, is that clear? So all you need to do to set up a new site is just simply create a copy. Let's Austin, is it with 2 rows? I can't even remember. And you're ready to rock and roll. You're ready to go. As long as you just fill in all this data. That's all you need to do. And also copy a new version of this, basically. So you just call that. And then you're ready to go. So it's pretty simple. Any questions at all? And then I'll just quickly go through, because I'm wary of the time. I'll go through the example of registering some images using Photoshop. I haven't been following the chat, so we'll stand in Dutch, I'll stand in English. There you go. I was mixing the two. All right. So good to see people chatting, making contacts. That's good. So final thing, I'll go quickly. I think you'll find in the URL that I sent around, there's even a list of instructions here to do this. So have a look at that, but I'll show you how it works to get to those aligned images. Now, we use Photoshop. We've tried, this is another development area where would be keen to get people to work on, and image registration can be a bit technical, and particularly the problems like CoastSnap, where you're dealing with images of varying size and resolution. So you're dealing from tiny Instagram photos to photos submitted by email of a big size, and because of that, it's quite a challenging problem to do. And we haven't found a open source solution yet, but Photoshop does a really good job of registering the images. So I'm going to show you how that you do that now. So this is Photoshop. I'm not sure, this is Photoshop Creative Cloud. I think it works on CS4, CS5 version as well. But all we do is, so I think we can just open default. So this is our Photoshop. So you'll see in the tool starter kit there is in processed, I think 2017. There's a whole bunch of images in here. So what I'm going to do, let's just have a look at these images. This is like what I was showing earlier. Oh no, it's not going to work there. Let me show it. And I just want to show you how it looks before, the raw images. CoastSnap. Okay, so you get the idea. They move around a lot. So what we do, and this you can just follow these instructions from the Word document. Go File, Scripts. So load files into Stack. So we browse, and this comes up with, these are the images we want. Now, you select a few. Now, the thing is with Photoshop is it starts to crash when you start to do more than, say, about 80 to 100. It starts to get a bit unworkable because I think it's a bit of a black box, but I'm guessing what it's doing is it's trying to find key points in the image and using some quite complex computer vision algorithms to do that. So it's a bit costly in terms of computational. But anyway, so firstly we load the layers. So what it's doing is it's loading these set of, I don't know, however many are selected, 40. While it's doing that, you'll see at Manly we have a target image. Now this target image is basically an image that we want everything to align to. So we tend to choose a sunny day, a typical looking image for that site. The other thing I'd suggest you do is try and get an image which looks quite, is more on the wider angle of the smartphone models. So this is a wider angle, so it covers quite a wide field of view, and that works better as a target image. Anyway, going back to our example here, you can see all of these images from the community submitted. You see all the different sizes from Facebook down to the original images. But the first thing what we want to do is find our target image. So I think that was on May the 23rd, this one here. So that's our target image. And the first thing what we want to do is lock it. So there's a button here called lock, and we've locked it. And what's that doing is telling Photoshop that it's not going to touch it at all, because we want everything to match that one. And then we go select all layers. So it's selecting all the images. And then the next step is edit, auto align layers. Now what we choose, there's different projections here. What we just choose is auto, and don't select anything else. Just keep it on auto and hit OK. So this takes a little bit of time, been cranking away there. For about 40 to 50 images, it probably takes about a minute, I'd say. But as soon as you get it more than 100 or so, it starts to just freeze almost. That's what I find, at least on my computer. Maybe others, maybe you have a supercomputer or something. But there you go. So it's aligned them all now. So the next step in this process is what we want to do is you can see that they still have different sizes and things, and that's because some other images cover different sections of the beach and are wider than others and so forth. The next step we want to do is to crop it. So we do that by holding on Control and then clicking on, if you see in this Layers tab, then clicking on that image. You see that's selected the, going back to our target image, that's selected that. And then we go Image, Crop. So now everything is with the exact same dimensions as our target image. And that's very useful for when we want to do rectification and things. It's in the exact same dimensions. Then finally, the final step in this process is simply to export it. So export, there's a thing in fact called Layers to Files. And it wants to put a prefix on, but let's delete that. And let's keep it on the quality to 12. And then we can put it in our registered folder. So, so we have our images, Manly. Let's put it in there, 2017. And then run. So what that should be doing is going through all those images. Look how stable they are now. And it's exporting them layer by layer. As I said, I'm not happy about using Photoshop to do this, but I haven't had the time to really look at it in detail to all right. So now we see all of our images in a nice, beautiful format, all in the same, the exact same. That's the target image there. You see it looks perfect, but all of them are now aligned up with that target image. Which is the final step which we do in MATLAB is then we actually we tag them. So we put a oops. Sorry, 1 sec. It's on the wrong screen. Sorry, I'm dealing with. Look. So you can see that now. So it's putting a tag on the top. It's reading the database and reading the tide level and the contributor and things like that. That's what we do. I've seen other people do differently. And there you go. So now if you is open. So now if you go to the, you can see we have the tags on it now. Oh, you can't, sorry. You can see that. And yeah, so that's the image registration process. Any questions on that at all? No? I had a question, sorry, someone on the chat said something. So I'm just trying to get to the chat. There we go. One trick, it's one trick. If resizing the online doesn't work, if you resize the images before this process to the same as the target image, that works better. Yeah, so what I actually do is I actually have seed images. So I actually have a seed bank of about 25 images, because what you find is that if you're only, you need to keep it kind of consistent, because if you, particularly if your coastline changes quite a lot, then the registration changes if you're registering it to a quite eroded coastline as opposed to a accreted one. So we always try and have a seed image that then we feed it with about 25 images of a seed bank, and then add additional images to that. Is a little tip that we do. And that, can you please show the output from the Photoshop file? I think I showed that just earlier. So yeah, there's the output. That's prior to tagging it. Alrighty, so that's about it for today. Thanks very much for your attention. If you have any more questions, more than welcome. So tomorrow is going to be more hands-on stuff where we'll actually set up, well, hopefully we'll be able to set up on your computer using that that setup with MATLAB and things, and get it actually running so you can map it on your computer. And then I'll give you tips on how to actually do the survey and then set up a new station from scratch. But you kind of get the idea. So if you're more interested in just a general overview like today, it's probably not worth attending tomorrow. But if you really want to learn the hands-on stuff, you're very welcome. And it would be great to have you there, okay? So thanks a lot. Thanks everyone for the messages. Hopefully see you tomorrow. Enjoy your days, everyone.
Bye.
Thank you.
Bye, Mitchell.
Thank you.
Thank
you.
you.
Bye.
Cheers, Mitch.
Thank you, Mitch.
Thanks.
Bye.
Everything.
Bye.
Good job. See you tomorrow.
Thank you.
See you tomorrow.
Thank you very much.
Thank you very much, Mitch. Bye.
Thank you. See you.
Thank you very much. See you tomorrow.
Thank you very much.
Thank you.
Bye. Thank you.